All right, what's the next term on this sequence? 1 over 32, then 1 over 64, 1 over 128. And if I want to get an expression for the a sub n term, if you're a little confused about it, I would suggest that you go with that little chart like I did on the previous problem, where I might say, okay, here's my chart. What exactly is happening? Here's the term number, and here's the term. And let me make a comment about term number. Well, I have started on the previous problem, and I called this term number 1, term number 2, term number 3. You really could probably start with whatever you wanted. Like I could say term number 0, term number 1, term number 2, term number 3. I could call it however I think it would work best for that problem. For this one, I'm thinking term number 1, I'm going to start with that. Term number 1 is 1/2. Term number 2 is 1/4. Term number 3 is 1/8. And as I'm looking at this, I don't want to look at the finished product for the term. I want to look at how did I get that maybe from the previous term? What's the pattern going on? What about this 1/4? I could call it two different ways. I could say that's the previous term times 1/2. Is that going to work for all of these terms? I think so. 1/8 is the previous term, which was 1/4, which was 1/2 times 1/2, and then times 1/2 again to get 1/8. And then 1/16 is 1/2 times 1/2 times 1/2 times 1/2. How does this relate to the term number? It looks like I could write 1 over 2 to the n. You could write it like this, 1 over 2 to the n. You could, since 1 to the n is 1, you could write 1 over 2 to the n like that. They're both correct. And I'll put my little ... It does continue. We're doing, in chapter 11, infinite sequences. It continues forever.